Now today I am talking about the disconnection of simple olefins. In this case, now the first example is this one. Now, as we already discussed in previous examples also, that whenever a target molecule is there, you ask some questions to the target molecule. In the same fashion, now you ask first question to the target molecule, do you have a functional group? Answer is yes. Now next question to the target molecule, which functional group? So answer for this, the functional group is double bond, right? So whenever the answer is your double bond, next question, now here we have to do some changes in this. Now next question that you have to ask to the target molecule, is this double bond present inside the ring or it is not a part of the ring? Now here the question of the answer is yes, it is a part of a ring or it is present inside the ring. Whenever your answer is the double bond is present inside the ring, then the best retro reaction is retro dehydration reaction. So what is dehydration reaction? Dehydration reaction means instead of double bond, now you have to add water molecule. Water molecule means at one carbon there is hydrogen and another carbon there is a hydroxy group. Now these are the two options. Either I can place a hydroxy group on this carbon or I can place hydroxy group on this carbon. These are the two options. But this is the wrong one. Why this one is the wrong one? The reason behind it that hydroxy group you always place at the hindered carbon. So this carbon is what? A hindered carbon. So you place always remember the placement of hydroxy group is at hindered carbon. So place the hydroxy group here. After placement of this hydroxy group, now the next thing is what? Again, now this is a new target molecule. Again, the same questionnaire. Do you have a functional group? Answer is yes. Which functional group? Answer is hydroxy functional group. Now, whenever hydroxy functional group is there, the specific question asked to the target molecule is whether it is primary hydroxy, secondary hydroxy, or tertiary hydroxy. So your answer is here what? It is now a tertiary hydroxy. Now, if it is a tertiary hydroxy functional group, then always go with the retro-Grignard reaction. Now, this is the option that we are converting, we are breaking the oxygen-hydrogen bond. So, indicating what? This bond acts as a guiding functional group. You would disconnect here and then disconnect here. Now, you may have a question, why we have not disconnect this bond? Why we have not disconnect this bond? The reason behind is, don't disconnect the ring bond. If there is no option, then of course we have to disconnect the ring bond. So now here we have an option that we can disconnect this bond. So generally don't break the ring bond because we are having another option over here. So you disconnect here, this indicate pH, MgBr and this cyclohexanone. Now complete the synthesis, the cyclohexanone plus phenyl magnesium bromide, then do the hydrolysis, get OH over there, and then complete the dehydration reaction by using H3PO4. And the next example. Now look at, it is again the same question asked to the target molecule, which functional group? So answer is a double bond. Whenever your answer is double bond, now next question that you have to ask to the target molecule, is it inside the ring or it is not a part of a ring? Now your answer is, it is not a part of a ring. Whenever the answer is, it is not a part of a ring, now as we already discussed in previous example, whenever a double bond is there, you just simply add the hydrogen and hydroxide group on this carbon. So look at here that at one carbon atom, we added a hydroxy group. In A, in B, what? The hydroxy group is added to this carbon. So these are the two options. Now, why these two options are wrong? The reason behind it, this hydroxy group, after dehydration reaction, it may have a double bond at this position, or after the dehydration reaction, it may have a double bond at this side. So we don't get a double bond. No doubt we'll get the product, but chances of getting the other product also. So this is the bad route. Now with B route, as the A route is not the proper one, if you go with the B route, so again B route, the same thing, that is I already explained, don't disturb the symmetry, so don't disconnect this bond, then it is a tertiary hydroxy group, again you do this and break this one. So it gives the acetone plus PaCH2CH2MgBr and complete this synthesis. But instead of this way, that is the retro dehydration reaction, instead of this, if we prefer a Wittig method. Now, what is the Wittig method? Now, instead of placement of hydrogen and hydroxide, instead of double bond, the best method is the Wittig method. Now, what is Wittig method? Wittig method means that you have to disconnect this double bond. Now, after disconnection of this double bond, the Wittig reaction is what? A reaction between the carbonyl group and Wittig reagent. This is the Wittig reaction. Now what you have to do, if you are going to disconnect this bond, now you have a choice. At one of the carbon you have to write double bond O, and at other carbon you have to write down the PPH3, that is the Wittig reagent. So where to write down the oxygen, whether you have to write down oxygen to this carbon or to this carbon. The best one is the placement of double bond O is here best one, because you get a known starting compound which is very cheap and readily available, that is the acetone. So placement of oxygen is here, that is the best method. So you'll get a acetone plus pH CH2 CH2, and here you have to write down the PPH3, that is the Wittig reagent. Now how do you get a Wittig reagent? Wittig reagent is obtained from alkyl halide plus triphenyl phosphine. So retro of this is alkyl halide and Wittig reagent, that is triphenyl phosphine. It gives you a Wittig reagent. Now in the synthesis, same triphenyl phosphine plus alkyl halide, then it gives you a Wittig reagent, and then you attack it on ketone, it gives you a double bond. Now here the placement of double bond is not possible here, it is not possible here. So this is the best method over the dehydration reaction. So whenever a intracyclic double bond is there, then we cannot go with the Wittig method. That time we have to prefer the retro dehydration reaction. But if the double bond is not a part of a ring, then we have to prefer the Wittig method. Now, the next one. Now, this is the target molecule. The same question that first of all you have to ask to the target molecule, do you have a functional group? The answer is yes. So, which functional group? The first functional group double bond is here, and the another functional group the double bond is here. Now, as we already discussed, that first of all, what you have to ask, if there is a double bond, whether it is a part of a ring or it is not a part of a ring. So, your first here it is a part of a ring, it is not a part of a ring, and this one is a part of a ring. Now one more feature you can see here, that is in previous examples I already explained, if there is a six-membered ring, a six-membered ring is there, and anti to that there is a intracyclic double bond, and anti to that if there is a substituent, then mostly you prefer a Diels-Alder reaction. So intracyclic double bond, exactly anti to that position there is a substituent. Therefore now we are not looking at this double bond, we have to focus on this double bond. So once you have to focus, once you come from the, you are not going to look at this double bond, we have to check this double bond now. Now this double bond is not a part of a ring, therefore which method is the best one now? Of course, Wittig method is the best one. Now the question arises whether you have to put the oxygen here or you can put the oxygen here. So which is the best method? As I already explained, so if you want to go with the Diels-Alder reaction, then this carbon has to have a carbonyl group or electron withdrawing group. So placement of oxygen here is the best one instead of this. So this part is the wrong one. This part is the correct one. So this placement of carbonyl group, that is CHO, and again PaCH2, CH2, PPH3. So this obtained from the alkyl halide plus triphenyl phosphine. Now how we can synthesize this? Now this how we can go with the retro of this double bond, and T2 that is a electron withdrawing group. So go with the retro Gill-Salter reaction and disconnect this bond in the direction of, that is a concerted type disconnection. So it gives you a butadiene, 1,3-butadiene plus vinyl aldehyde. Now complete the synthesis. First you synthesize the Wittig acceptor, that is butadiene plus vinyl aldehyde gives you Wittig acceptor. Then prepare the Wittig reagent. Once you get the Wittig reagent, then attack it on the Wittig acceptor and get the final product, that is your the target molecule. Now what we learn up till this, now again this is the summary part. Whenever a olefin, that is a double bond, is there in a target molecule, the two questions that you have to ask to the target molecule: is it a intracyclic double bond or there is no intracyclic double bond? If intracyclic double bond is there, you always go with the retro dehydration reaction. If the double bond is not part of a ring, then you go with the Wittig reaction. Now, if you are preferring a retro dehydration reaction, then always remember that addition of hydroxy group at hindered carbon is preferred. So that you always remember. That I already explained. You go through this book, Designing of Organic Synthesis by Warren.